So hello everyone, my name is Sujay Torvi. So let's talk about TRAVIGATE. TRAVIGATE is an artificial intelligence based app that was developed to improve the experience of tourists. So what is TRAVIGATE basically? When any user who is wanting to go for a vacation but is confused where to go. Here TRAVIGATE makes people's life a lot easier by recommending places that they would love to visit. Nowadays many people use smartphones. Given how essential mobile has become, it becomes very easy for developers to improve people's experience using apps that harness the power of machine learning and AI. So what algorithms does TRAVIGATE exactly use? It uses K-mode clustering that is used to recommend people places, and convolutional neural network is used to identify new places that the tourist has never visited. What dataset does this app use? As we can see, three datasets are being used. The first one is the user dataset that stores the user info such as their personal data and the types of places that they would like to visit. The reviews dataset consists of the numerous reviews of users that they have been in previous places, whether a place can be recommended or not. The images dataset is scraped from Google. It consists of lot of images of tourist spots, which is then used to train a model that will allow a user to know the type of place and the place he is visiting by just clicking a picture through his smartphone. So let's see what inference engine does our expert system use. K-mode clustering is a machine learning algorithm. When the user runs the app asks many details of the user, like his age, number of family members, and where has he toured in the past, and groups him into what is called as cluster. A cluster will represent a group of similar people based on preferences. Each cluster can be recommended some tourist spots. For example, a cluster where people love hill station will be recommended tourist places that are related to hill station. Convolutional neural network is a special kind of neural network used to predict images. It is used in fields such as computer vision. Convolutional neural network is trained on lot of images of tourist spots. A user can take a picture of a place using his phone camera and know the place that he is currently visiting. So now my friend Raj will explain all the related work and the user interfaces used by the expert system.
So hey guys, let's talk about the related work in this field. In the literature, there are several studies about the user habits and routines in the city using digital traces. Some of them are analyze GPS data and cellular footprints of the user to understand, for instance, their usual trajectories. So in the following table, we can see the differences and the similarities between the Google goggles and our proposed system. The input is in the form of image in Google goggles, whereas in the form of image and text in the proposed system. The output shows the image recognition, which is similar in both, whereas it gives the name and details in case of Google goggles, whereas in a proposed system, it suggests the nearby places in the given city based on the user interest. In the image category, it gives the images of the monuments, famous buildings, and much more, whereas a proposed system gives the images of the hotels, attractions, and restaurants. Now moving on to the recommendation system. What is a recommendation system? A recommendation system is a personalization tool that offers users with a list of items that best fit their individual taste. A recommendation system analyzes the available data and recommends the items according to the user interest. The more the system understands the interest of the user, the better recommendation it can perform. It consists of two parts, a collaborative filtering and a recommender system. Collaborating filtering is the process of filtering for information or patterns using techniques involving collaboration among the multiple agents, viewpoints, data sources, etc. Collaborating filtering is divided into three steps. First, the representation of the tourist information, whether travel, style, or reviews of the users are checked. Next, the similarity of the tourist are computed according to the visiting history. Third, the generation of the attraction recommendations on the basis of the similarities with other similar users, top attraction, and etc. Now, moving on to the recommender system. A recommender system uses a subclass of the information filtering that seeks to predict the rating or preference that a user would give to an item. In a trip planning, a user is interested in suggestion for the point of interest that could be heterogeneous, example museum, park, restaurants, which can benefit a system which is capable of recommending items organized in packages rather than ranked list. Now, let's talk about the user interfaces. We know the user interface is the interaction between the user and the machines. Here we can see that the user or the tourist may enter the login credentials and details based on the GUI based application. Now the request for places hits the web server accordingly. Now it shoots the JSON query and learning of clustering on the basis of user attributes in the database server takes place. Now the results based on the clustering hits back the web server and the web server gives the recommendation, places, hotels, attraction, restaurants and much more. Now the GUI will help the tourist or the user to view the recommendation. Now Rajeshwari will explain the methodology.
As we have already seen how a user interfaces with our expert system, we'll see the methodology that the expert system uses. The first part here is the place recommendation system. As we know that the system consists of a MySQL database, a web server, and a front-end application. The process that takes place is the data cleaning and the data pre-processing. Now the initial step, the data was initially in the form of .csv files and it has to be converted into a MySQL database. The next part is the data set also requires the cleaning and removing redundant or missing data from the datasets. Moreover, it was also necessary converting all the data into a categorical data. The next after the cleaning and the pre-processing is the recommendation using the K modes. The users are clustered using the K modes clustering algorithm, where the total number of clusters can be n or n greater than 2. As the number of cluster increases, the number of users in each cluster decrease. For example, if a user wants recommendations for places to visit in Mumbai, the system would recommend places in Mumbai which has been visited by the user in the same cluster. The next procedure is the place recognition system. What happens here? The first part here is the image scraping. To create a sufficiently large training dataset for different places, they have used a web scraping technique. Now, what is a web scraping technique? The first 100 images of a Google search of that particular place are scrapped. In the image search page created by the Google, the first 100 websites are visited and the images from those websites are downloaded and stored in the individual folders. The next is initializing the CNN. The CNN is the convolutional neural networks. There are a number of important choices that need to be made when we are building and training a neural network. We had to decide how many layers to have, what stride and kernel size to use for each convolution layer, and more. For this, initializing CNN is important. The next is the convolution. After procuring these images and initializing the weight, the next step is the application of the convolution layer. Convolution is basically a mathematical operation which provides a way of multiplying two arrays of numbers, provides different ways of generally of different sizes but of same dimensionality to produce a third array of the number of same dimensionality. The next is the pooling. A pooling layer is periodically inserted in between two convolution layers. This layer is used here to downsample the volume partially independently in each depth slice. This is used for the maximum pooling between two convolution layers.
My name is Tir Desai. I am here to present the result of my paper. We have used K-method clustering that classifies the user into 4 clusters based on their attributes. This can be age, number of hotel reviewed, number of first to review, number of ratings and many more. For this, we have taken 100 test cases of places with 2 similar users, one which has reviewed the place and another which has not reviewed the place. 3-star and above are categorized into suggested places while rest are categorized into not suggested places. Now we'll be going to down to the paper T. The chart is called to be the confusion chart. On the left hand side, the suggested places, 249 places are suggested and 77 places are not suggested by the app. So these 77 places were to be suggested but are not suggested. Now not suggested places, 646 places are not suggested but 28 places are suggested by the app which weren't to be suggested. So looking to this chart, we can say that the accuracy of our app is not 100% but it's fine. The tourist can use this app to get the best results the app can produce. Now we'll be moving to the next slide. We have used CNN model. In this CNN model, we have first taken 50 steps per iteration and then increased gradually. From 50 we have moved to 75 and from 75 we have moved to 100 steps. As we can see in the image below, when we took 50 steps, 32 steps were accurate, and when we moved to 75 we can see that 38.9 were accurate, and when we have gone to the 100 steps, we can say that 46.4 steps were accurate. So from this we can give a central idea that our app gives us the accuracy of 46.4%. Now we'll be moving to the conclusion of our paper. The central idea is to reduce the efforts of trip planning. When the user provides some images to the app recognizes these images and gives the minute detail of every places of that particular city. We have used K method for the clustering. Convolution neural networks are used to train the system. For better place recognition, we have used convolution neural networks. Our app provides us good accuracy and can be used by many tourists. As we can see that every paper has some future scope, even our paper have future scope. We first have to give focus on the accuracy, like our accuracy must to be improved. We can increase the size of database. By increasing, we can add lots of places, and these places can be for later useful for the tourist to visit these places. Feedback can be taken by the tourist. Creation of a learning system, like if a tourist goes to visit some places, the feedback will be taken, and our app can be made a learning system, like on the basis of the feedback our system will be learning. Here I end my PPT. Thank you so much.